This is Daniel Coosbury, and in this lecture, we're talking all about simple interest. So this is simple interest is a context in which you're putting money into some kind of account, and it's going to pay out this constant interest rate every single year for a certain number of years or parts of years and things like that. You can also think of this in the context of you're pulling out a loan, and you're going to have to pay that loan back with a certain interest or with a certain interest rate applied to it after a certain number of years. And so anyway, simple interest is really nice because there's really just this one formula that describes how it goes. So we have two formulas total, but they're related. So this first one is used to calculate just the interest part, and kind of like in those discount rate and sales rate problems, once we get that interest, we can tack it on to the original amount and describe the amount that you're going to have at the end of the day or have to pay at the end of the day or something like that. And then we also have a formula that kind of finds that future amount all at one time. So we'll look at both of those, but simple interest is pretty nice because there's only a few factors here. There's the interest part itself. There's the principal amount, which we're going to consider the amount invested or the initial amount. Then there's the interest rate, and then there's time. And note that this time in our problems are going to be in years. So any context we see a certain number of years or a certain number of months, we're going to have to convert to years. We're thinking about time in years. So let's just start with an example. Here you deposit $10,000 into a savings account, which yields 4% simple interest. And then the question is, what will be the interest after 1 year? So we can find the interest just by using this formula by saying, okay, well, the principal amount or the amount I start with or I invest is $10,000. The interest rate is 4%, which we'll want to write the 4% as a decimal. We can do that. So this is going to be 0.04. And the time is in years, and we said, what's it going to be after 1 year? So the time is just going to be 1 in this case. So this is what I'm doing. I'm multiplying 10,000 times 0.04 times 1, and I end up with 400. So if you invest $10,000 into an account that yields 4% simple interest, you're going to earn yourself $400 in a year. So that's pretty nice. Now, where interest gets more interesting is when you invest after several years. So here's another example. You deposit $8,000 into an account that pays 5.5% interest. I just changed some numbers, and I increased the number of years, and we're still just wondering what the interest is. So I'm going to use this formula again. The principal amount is 8,000. That's the number you start with. The rate in this case is 5.5. Now you see that decimal, don't let it throw you off. This is the number 0.055. You got to move the decimal 2 places to the left to get the rate, so that's 0.055. And the number of years is 12. So now I've got a couple more numbers to multiply here. Once I do that, I calculate that my interest is 5,280. Okay, so the number of years you invest makes about as much difference as anything else in these problems, so that investing a lot of money for 1 year doesn't yield nearly as much as investing a little bit less money for a little bit more interest after 12 years. But so anyway, that's kind of the basics of calculating the interest itself. Now, more interesting formula, maybe a more helpful formula, is calculating just how much your account's going to be worth after a certain number of years. So we're going to call that the future value. So after a certain number of years, how much is that investment worth, whether that investment is something you put in or whether it's a loan you take out or something like that. But we're going to call the future value the amount that the account is worth after a certain number of years. And for future value, we'll call it A. You just have the same kind of parts as you do when you calculate the interest. So this is the principal amount, what you start with. There's the interest rate, and there's time again. And note time is in years still. And I'm going to kind of highlight that in this example. So we want to find the future value of a loan where the loan starts out at $2,300. The rate is 3.4% and it's simple interest, and it's for 3 months. Okay, so here's where we got to think again. Time is in years, and now they tell us something about months. So let's just go ahead and start plugging stuff into this formula. The future value is equal to the principal amount times 1 plus 0.034, that's my rate, times, and then I need a time there. And okay, so if time is in years, and in that first example, 1 year was 1. 3 months is not even a whole year, so that can't be 1. T's got to be equal to something less than 1. 3 months out of 12 months, that's a quarter of a year, so maybe we can just write this as 1/4. How about that? Since T is in years, this is a quarter of a year, so that's going to be 1/4, that T right there. Okay, and I can type this into my calculator just like this. Order of operations is going to work just fine. If I put parentheses here and a multiplication sign here, it should do everything in the right order. So I'm just going to do all this in one step in my calculator, and it should work out. Actually, let me comment real quick. The only place you probably wouldn't want to do, you probably want to put another set of parentheses around that 1/4, and then the calculator will handle it fine, because it likes to mess with the multiplication and division sign. So yeah, punch in the calculator like this now, put a parentheses around the 1/4, and you should end up with this answer. Okay, so that's the future value of the loan. It looks like the number increased by $19.55, which is shouldn't be that surprising, because it's only been invested for 3 months and the interest rate isn't terribly high. But for the most part, most investments, even in a short amount of time, don't really grow that much unless the interest is huge or the initial amount is huge. But anyway, this is how this formula works. It's really not that bad. You have the P, the R, and the T, just like in that regular simple interest formula. Except this one's a little nicer, because you can just go ahead and get what you really want to know, and that's like, what's your account going to be worth? So let's look at a fun problem. So here's I like this problem. Here's a problem that considers a hypothetical where you spend $3.50 each day, 5 days a week on coffee, maybe at a coffee shop or something. You stop by there on the way to work and you pay $3.50 on each day. One question is, how much do you spend on this item in a year? In other words, how many cups of coffee, or how much are you going to spend on cups of coffee at a coffee shop if you do spend $3.50 on each day, 5 days a week? So this isn't a hard thing to figure out, because let's see, if I'm spending this much money on it a day, 5 days a week, and then if I do that every single week in the year, let's just forget about holidays and stuff. Let's just assume that I'm doing it every day, 5 days a week, for 52 weeks out of the year. Then this is going to be the number. That's how much money I spend just on coffee from coffee shops in a year. Pretty significant number. So if you're the type who stops by a coffee shop every single day on your way to work, and you get something that costs $3-ish, $3.50-ish, this is how much you're going to spend. Maybe on average. Maybe this might be a little high, but anyway, it's a fun little problem. Now this problem really comes into play in part B. It says if you invested your yearly spending on coffee, so this yearly spending on coffee would be this number we just calculated. If you invested that number in a savings account yielding 5% simple interest, how much would the account be worth after 1 year? In other words, try to imagine a situation where instead of getting coffee every day, you didn't get coffee every day, and instead took all that money and you put it into a savings account for a year. And I guess the question is, like, how much money are you going to have if you do that? So let's use the future value formula. When you see this sort of question here, how much will it be worth after a year, or how much you're going to have after a certain number of years, that's future value. So future value is going to be the present value, which we calculated, this principal value. That's how much money we would have spent on coffee, times 1 plus the rate, 0.05, times the time, which is 1. 1 year. There's not much to think about with that one. And if I do all that in my calculator, I think I can type that the same way I wrote it. You got to watch out for order of operations, but this should be fine. I end up with 955.5, and I'll put a 0 on there because we're talking about money here. That much money. So I end up making like $45 if instead of spending all that money, I invested it. In fact, actually, after a year, if you drink this much coffee 5 days a week, you find yourself out $910. Whereas if I don't do that and I invest that money, I end up making $50 instead of spending $900. That's all I'm going to say about that. Okay, so we're going to look at a couple other aspects of this formula because it is a formula that has a bunch of different pieces. And so based on the situation, we might want to know one piece instead of another piece. So, and I'll kind of show you in these last two examples. So what we've done so far is we've started assuming we know how much we're going to put in and the rate and the time, and we want to find future value. Here's an example where we're borrowing $4,000 from a friend, and we promised to pay them back $4,500 in 8 months. And in other words, you made some sort of agreement ahead of time, like I'm going to pay you back more than you paid me, like you're going to get interest. And I guess the question is, well, what's the interest rate you're going to end up paying? Another cool question might be, what's the actual interest? Well, I guess that'd be $500. But the idea is that you're going to pay them more. What's the rate? Is it a fair rate? Is it not a good rate? So we can find this rate simply by plugging in all the things we know into this formula and leaving one variable as a variable because we don't know it. In this case, it'll be the rate. We won't know what that is. So we'll just leave that as R. My future value is $4,500. That's how much I'm going to pay them back in the future. My principal value is $4,000. And then there's a 1 plus R times, and then T should be the number of years. Let's see, here's 8 months, 8 out of 12 months. How many years is that? That's equal to 2/3 of a year. We can just use 2/3 there. Hopefully that works. Okay, so here I have a nice little algebra problem. I want to know the interest rate, which means I have to solve for R. So that might be a little bit of a pain. So let's just do the algebra and see how we do. So I'm going to start by distributing this 4,000 into here. And I end up with 4,000 plus, and I'm going to see what this is in my calculator. 4,000 times 2/3. Oh, that's messy. I'll multiply it like fractions then. I'll do 4,000 times 2 divided by 3. This is 8,000. 4,000 times 2 divided by 3 times R. Just going to see if that helps me out. So that's this. This is that. This is just that. I just multiplied the 4,000 by 2. Okay, I want to solve for R, so I'll subtract that 4,000 from both sides and end up with 500 on the left-hand side and 8,000 divided by 3 or on the right-hand side. So you see what I've tried to do is I left this fraction intact because it was going to get messy. And now I can multiply each side times 3 to get rid of that. So if I do that, that goes away, and I end up with 1,500. It's equal to 8,000 R. And then I'll divide both sides by 8,000. So this will be 15,000 divided by 8,000 is equal to R. And I might want to do that in the calculator just to see what that number is. That ends up being 1875, which is 18.75%. It's pretty hefty rate. So that's how you would do this problem. You use the exact same formula to find future value, present value, and all this stuff. You're just plugging in everything that you know and leaving the one thing you don't know blank. Then you got to do the algebra. So this rate is pretty high, but it's somewhat believable because the fact of the matter is your friend, in this case, is going to end up making $500 in 8 months. And the only way to do that off of investment is to have a huge investment, which this isn't, it's big, but it's not that big. Or to have a really high interest rate, which it turns out it's 18.75% interest rate. He's making a lot of money off of you in just a short amount of time. So that's that. Okay, another situation where we're going to want to use this formula for maybe different reasons is maybe we're imagining a future in which we have a certain amount of money and we want to invest some money now to get that money in the future. So the idea is maybe we know what our future value could be, like that's our goal in life, maybe is to have this much money in a few years. And we have our interest rate options, and we have a certain amount of like a timeline, like I want this to happen in a certain number of years. And the question is, what should I invest now in order to get this future value? So here's the situation. We want to save up $2,500 to visit Disney World in 2 years. And the question is, how much money will you need to invest in an account that pays 4% simple interest in order to have this $2,500 2 years from now? So the idea is, again, I want to know how much I need to invest now. Maybe I don't have the $2,500, but how much should I have to invest in order to get that just from earning interest and stuff? So I'm going to just start plugging things into this formula again. The future value, or the goal in this case, is $2,500. The principal value, the amount I'm investing, is the thing I don't know. I don't know how much I need to put in order to have that result. So I'm going to leave that as a P. This is a 1. My rate is 0.04. And my time is 2 years. It's nothing tricky there. So I'm going to work through the algebra again. And in this case, I'm solving for capital P. So let's start by working, kind of simplifying this number right here. It's not going to take us very long. So there's nothing to do on the left-hand side. There's nothing to do here. But this number is 1 plus 0.4 times 2, which is also 1 plus 0.04 times 2. This is 0.08. I'm just kind of working through this, simplifying this number. This is P times 1.08. Okay, so now I can divide both sides by 1.08. So if I do that over here, I do that over here, and that goes away. And I'll just do this in my calculator. And I end up with P is equal to 2314.81 dollars. So if I'm looking at a situation where I'm going to invest money for 2 years into an account that pays 4% simple interest, and I want to eventually have $2,500, this is the amount I need to invest initially, which is almost $2,500. But again, the only way you're going to make money off an investment is to either invest a lot of money or invest it for a long amount of time, or to have a great interest rate, which is hard to find. And there's these 3 different factors that go into it. Anyway, the point of this example and the one before it is that you can use this formula for more than just finding the future value. If you have a desired future value, you can find out other things based on the information you have. So if there's 1, 2, 3, 4 variables, all you need is 3 of them to solve for the last one, whether it's solving for A like we did at first, or solving for R, or solving for B. You could also imagine a situation where I have a desired future value, and all I want to know is how much do I need to invest, or how long do I need to invest something for? So I'm investing $1,000. How long until I have $3,000? Well, you're wondering what T is, so you'd solve for T. Anyway, I think I beat that dead horse. So anyway, that's simple interest. You're really just leaning on this formula and the original interest formula, but they work really, really similarly, and I hope all this helps.